All right, today's lesson is on dividing polynomials. We're going to do that using our classic long division algorithm. So this is just like you learned long division in elementary school, like way back in 4th grade when you first learned how to divide. So to review, let's say I asked you to take a fraction, a top-heavy fraction here, 67/5, and write it as a mixed number. So that would be like, 4 3/7, or some value like that, right? Those are our mixed numbers. So of course we would do this, we're going to divide. And so we've got our division set up over here. And the first thing we do is figure out how many 5s go into 6, right? We're kind of looking at these two. And understanding and remembering this algorithm is going to be imperative to the rest of the lesson. So if you get lost here, you may need to rewind and watch this part again. So we want to figure out how many 5s go into 6. And in this case, 1. Okay, so remembering what we do with this 1 is we multiply it by 5, and we write the result underneath. So 1 times 5 is 5. And then we need to subtract that value. Now normally we would just subtract our number. I am going to put in some parentheses this time. I know they seem unnecessary there, but we will see them with polynomials later. So we want to divide this whole line, subtract this whole line, right? So 6 minus 5 is 1. So we drop down our 1, and we drop down our 7. I'll write that a little closer. So now we have 17. We want to figure out, we basically start this algorithm again. How many 5s go into 17? Well, 5 times 3 would be 15, and that's as close as we can get without going over. So again, we multiply. 3 times 5 is 15. And we need to subtract this entire line again. So again, the parentheses, usually we wouldn't write, but we will need them today. So go ahead and subtract. 17 minus 15 is 2. And notice this is where my decimal would be, right? Or we can add a 0 and drop down a 0 and put a decimal here if we wanted to get a decimal answer. But instead, we're going way back to remainder math. So if I get to the end here, there's no more numbers to drop down. This is our remainder, right? And 5 doesn't go into 2. It's too big, so we end up writing remainder 2. So what does that mean? 5 went into 67 13 times, and we had 2 left over. And the way that we write these answers, our mixed number here would be 13 and 2/5 remaining. Okay, now this doesn't mean, well, technically you could write it as being times. This doesn't mean times, sorry. This doesn't mean times. This means 13 and 2/5 together, right? That's what those mixed numbers really stand for. And the way that we write these answers that have remainders is in this form. The quotient, that's our answer up here, plus the remainder, which was our 2, over the divisor, and that's what we were dividing by, 5. So 13 plus 2 over 5, that is our quotient, plus remainder over divisor. Okay, so that's how we write our answers. Okay, so I'm going to give you a problem to practice here, because again, if you struggle with this or you can't remember the steps, it's going to be really hard to do with expressions. So here's one. Try this one out, right? 123/5 as a mixed number. Okay, also put in these parentheses like I did here, even though they're somewhat unnecessary for this version. But try that out. Pause the video and then resume when you're ready. All right, how did you do? Did you come up with 24 remainder 3, which we would write as 24 and 3/5? That again is our quotient plus remainder over divisor. So again, 5 does not go into 1, so we'd write our 0. It goes in 0 times. So then we think about this as being 2 digits, the number 12. 5 went into 12 twice. 2 times 5 gave us the 10 down here that we subtracted. And 12 minus 10 gives us 2. And really we drop down this 3. 5 goes into 23 4 times. Remember, 4 times 5 gives us the 20. And then we subtract. And that left us with 3. And that's where we're at the end of our number. We could either make a decimal or we're going to write a remainder. 5 doesn't go into 3 anymore, it's too big, so we were left with a remainder of 3. Okay, if you've got that and you feel confident in this algorithm so far, then let's keep going. All right, so let's say we multiply two numbers together, 13 and 5. Okay, that would get us 65. Here we could say that 13 and 5 are the factors of 65. They're the values we can multiply together to make 65. So what should we get if we divide 65 by 5? So if I take this and divide it by one of its factors, what should our answer be? Hopefully, you're saying 13, right? It should be our other factor. So in a similar way, if we multiply two expressions together, and it gives us a bigger expression, in this case a quadratic, what happens if I take that quadratic and divide it by one of its factors? What answer should we get? We should get its other factor. So we should get x plus 5 as an answer here. So just like 13 and 5 are factors of 65, x plus 5 and x plus 3 are factors of this quadratic. So let's do this actual division. Let's divide x squared plus 8x plus 15. This is the same example we just did here. And let's go ahead and divide it by x plus 3. What answer should we expect? We should get x plus 5. What remainder should we get? If it's one of our factors, there should be no remainder. So we should get a nice remainder of 0. Okay, so let's set this up. So x plus 3, we're dividing this, so this goes inside, by x plus 3, which is what goes on the outside. All right, so I brought in the problem that we did on the first page. Our first example we did, we wrote 67/5 as a mixed number, just so we can reference the steps that we did. So here's how we do our long division. Remember in our first part, we wanted to say how many 5s go into 6. Okay, how we do that with polynomials is we're going to look at the biggest term in each. Remember, terms are separated by addition or subtraction, so we're looking for the highest powered term. So here that's x to the first and x squared. We want to figure out how many times does x go into x squared. And to do that, we're going to take x squared, the one underneath, and divide it by x. And this is why we were just doing those properties of exponents. Here, we can cancel out one x between the top and bottom, and we'd get x over 1, or x. So we'd say it goes in x times. Okay, now here we said when our 5 went into 6 one time, remember what we did with our 1 was multiply it by 5 and write the answer underneath. Okay, we're going to do the same thing. Here we need to multiply our x by the divisor, but we do need to distribute. So we need to multiply all terms by x. So x times x would make x squared. We're going to line that up underneath our x squared. And x times 3 gives me positive 3x. We're going to line that up underneath our x to the first. Okay, now remember in our next step we subtracted that 5. And here's where I said we would need parentheses today. So we're going to subtract this entire line. Okay, and we're going to do that, in this case, because we need to subtract both terms, we're going to do this by adding the opposite. Subtraction is the same as adding the opposite, and doing this will just help you make less sign mistakes here. We're going to change this to adding, and make everything inside the parentheses the opposite sign. So this is now a negative x squared and a negative 3x. Okay, we both started positive and now they're negative. And then we're going to add or combine like terms with the ones above. So positive x squared and negative x squared would cancel. So these go away. Positive 8x and negative 3x make positive 5x. Okay, so we did our subtraction. This is equivalent to doing like 6 minus 5, and that gave us the 1. And then we drop down our 7. So in a similar way, we would drop down the rest of the polynomial, which in this case is just the plus 15. Okay, so referencing back up here, this is like when we got 17, and we basically kind of start the whole thing over again. So we're going to look, how many times does x go into 5x? By dividing, the one from underneath goes on top, 5x divided by x. Well, again, practicing our exponent stuff, we know we can cancel those x's, and we'd get 5 over 1, or positive 5. So we're going to write plus 5. Hey, this is looking pretty good, right? Remember, this is what we should expect. So remember, just like before, we need to take our 5 and multiply it over here. Okay, again, this would just be like figuring out 5 went into 17 3 times. And then you do 3 times 5, and that gave us 15. So that's the step we're at here. So 5 times x gives us 5x. And then 5 times 3. Don't forget we have to distribute to all terms. That gives me 15. But remember, again, we are subtracting this entire line. And we need to do that by adding the opposite. So we're going to change this to adding the opposites. Again, they both started positive, so they've become negative now. Positive 5x and negative 5x would cancel. Positive 15 and negative 15 cancel, and we get 0. And this is as far as I can go. If in your divisor we get to the constant, like something without a variable or power, that means that we're done, and any results we get down here is our remainder. So don't forget, we write our answers in the form quotient, oops, we'll just reference right here, quotient plus remainder over divisor. So my quotient would be x plus 5 plus our remainder, which is 0, over the divisor, x plus 3. However, if you get a remainder of 0, we don't need to write this extra expression. Okay, only when it's not 0 we would. So in this case, we can omit the remainder over divisor since it went in perfectly. And our answer is the expression x plus 5. And that's what we expected. We expected to get x plus 5 because we knew ahead of time this was a factor. Okay, normally we wouldn't know that, but just for practice we knew that. And we knew we should hopefully end up with a nice remainder of 0. So that's a good way of checking our math. Okay, here's another example. This is the same quadratic, but now we're dividing it by something that is not one of its two factors. So we should end up with a remainder here. Okay, so let's try this out. Again, walking through these steps, the first thing we want to figure out is x squared divided by x. So the biggest term in each, we go off to the side, x squared divided by x. How many times does that go in? And we could cancel one set between the top and bottom, and we'd get x over 1, or x. It goes in x times. Now remember, we need to distribute our x to both terms. So x times x would be x squared. We'll line that up underneath our other x squared. And x times negative 2 would be negative 2x. And we'll line that up under our other x to the first. Here's where we need to subtract our answer. And to make our lives easier when we're subtracting, we're going to change this to adding the opposites. So we just change all the signs in there, and then we're just adding terms. So my positive x squared and negative x squared should cancel. 8x and 2x makes 10x. And then we can drop down the rest of our polynomial. Okay, now we basically start over again. 10x divided by x. 10x divided by x. Well, we can cancel the x's between the top and bottom, and we'd get 10 over 1, or positive 10. Okay, just like before, now we're going to take the 10 and distribute to both parts here. So 10 times x is 10x, and 10 times negative 2 is negative 20. We're going to subtract this entire line, and remember we can do that by adding the opposite. So we can change this to an addition problem if we make everything inside of our parentheses the opposite sign. Okay, so our positive and negative 10x will cancel, and we end up with 35. Now again, we could tell that we're at the end, because this is a constant at the end here, doesn't have x anymore. Or if I tried to start over and do my division, if I tried to do 35 over x, if we've got more x's in the bottom than we do up top, we've gone too far and we're into the remainder. Okay, when they're equal, there's an equal number of them, we can keep going. But if there's more x's in the bottom than the top, we've gone too far. This is the remainder. So our 35 is the remainder. So remember, we write our answers in the form quotient plus remainder over divisor. And this time we do have a remainder. So my quotient is the x plus 10. My remainder is positive 35. And my divisor, what we were dividing by, is the x minus 2. And that's how we'd write our answer. X plus 10 plus 35 over x minus 2. Okay, here's another example. 6x squared minus x minus 2. And this time we're going to divide it by 3x minus 2. So again, we're going to start the same way. We're going to look at the biggest term in each, okay, highest degree term, and divide them off to the side. 6x squared, this one goes on top, divided by 3x, and that one goes on bottom. So we're going to simplify our expression here. 6 divided by 3 is 2. And x squared over x, remember we can cancel one set of x's, so we'd be left with 1 up top. So we'd get 2x over 1, or 2x. Okay, now remember we need to take our 2x and distribute to all terms here. So 2x times 3x is 6x squared. And 2x times negative 2 is negative 4x. We need to subtract this whole line. And remember that we're going to do that by adding the opposite. So we're going to change this to addition, make that the opposite sign, and make that the opposite sign. So our negative 6x squared and positive 6x squared cancel. And negative 1x and positive 4x gives us positive 3x. Then we're going to drop down the rest of our polynomial, the minus 2, and we're going to try again. 3x divided by 3x. So this was the one that's going on top. And we still have at least an equal number of x's here. And in fact, anything divided by itself is 1, right? 3 divided by 3 is 1, and our x's cancel out and give us another 1. So we end up with positive 1. So distributing a 1 should be easy. 1 times 3x is 3x. And 1 times negative 2 is negative 2. We need to subtract this line. And we're going to do that through adding the opposite. So add the opposites. Okay, we've got some stuff that cancels out. Our positive and negative 3, ooh, and our positive and negative 2. And I think, because we're down to a constant here, and or of course if I did try to divide these 0 over 3x, we definitely have more x's in the bottom than up top. This ends up being our remainder. So if we were writing this in our form, quotient plus remainder over divisor, our quotient is 2x plus 1 plus our remainder over our divisor. But again, as we said on like the first slide, if my remainder is 0, we don't need this expression. We can omit it. And we can say our answer is 2x plus 1. So what does it mean that we got a remainder of 0? That tells me that 2x plus 1 is a factor of 6x squared minus x minus 2. Because we got a remainder of 0, right? And in fact, our divisor, of course, is also the other factor. I meant to say 3x minus 2 is definitely a factor, and of course we found the other factor by dividing, right? But either way, they are both factors. So we found the two factors. If we ended up dividing by 1, which was this, we get the answer of the other, right? It's like, again, if we said if I took 65 and divided it by 13, we'd get 5, right? We'd get our other factor. Cool. All right, we got a couple more examples, 2 more to go. All right. Whew. let's take a look at this thing. So we've already got it set up here. And again, we're going to divide our largest terms off to the side, x to the third over x. And here, when I cancel out one set of x's, we get x squared. X squared times x is x cubed. So I'll line that up under my x cubed. And x squared times -1, negative x squared. Line that up underneath my other x squared. Okay, subtract this line. And we're going to do that by adding the opposites. So add the opposites, and now we can get rid of some stuff here. Those cancel out. Negative 4x squared and positive 1x squared make negative 3x squared. So then we're just going to drop down the rest of the polynomial, our 2x and plus 7. And then we repeat. Divide these off to the side. Negative 3x squared divided by x. Okay, it gives me negative 3x. Right, we can cancel one x between the top and bottom. So we get negative 3x. Multiply this again by both parts here. Negative 3x times x is negative 3x squared. Line that up. Negative 3x times -1 makes positive 3x. Once again, we're going to need to subtract this line. And we do that by adding the opposites. So add, make that the opposite, and that the opposite. So that's a negative 3x over there. And now we can cancel those. Here we end up with negative 1x plus 7, right? Drop down our 7. So we can try one more time, I think. Negative x divided by x. At least have an equal number of x's here. This ends up giving me negative 1. Right? Remember, we could say our x's cancel, but they're really reducing to a 1. And so we end up with negative 1. So minus 1. Well, we still need to distribute again. Negative 1 to both parts. Negative 1 times x is negative x. And negative 1 times -1 makes positive 1. Subtract our line again by adding the opposites. Add the opposites, okay? And now our x's cancel out, and we end up with positive 6. And again, we're at our constant. We definitely can't go any further. And if I did try to divide these again off to the side, I know I've gone too far because I have more x's in the bottom than in the top. Okay, they at least need to be an equal number of them. So that 6 is our remainder. So because we didn't get a remainder of 0, I could say x minus 1 is not a factor. But we write our answer again in the form quotient plus remainder over divisor. So my quotient is here, the quadratic, x squared minus 3x minus 1, plus our remainder, which was 6, over our divisor, x minus 1. And there's our answer. We ended up getting a quadratic. And holy moly, look at our last example here. It looks like we've really stepped up our game, but in fact, it's actually going to be a little easier. Okay, well, let's try this out. Same idea. We're going to take the largest term in each and divide them off to the side here. 2x cubed over 2x squared. So my 2's would reduce to a 1, so those go away, and I can cancel two x's, two sets of x's between the top and bottom, and I'd get x over 1, or just x. This goes in x times. Now when I go to distribute, though, we do have to distribute to 3 terms. So x times 2x squared makes 2x to the third. Oops, 2x to the third. There we go. X times -5 is -5x squared. Again, we're lining these up. And x times +3 is +3x. And again, line that up. So now we do need to subtract this entire line. And again, we'll do that through adding the opposite. So this becomes plus, negative, that becomes positive, that becomes negative. Good. So we changed all of our signs, and now we're just adding. So my x cubes cancel. I get -6x squareds. Here we're going to get +15x and drop down the -9. Okay, and then we're going to repeat. Divide these off to the side. Negative 6x squared over 2x squared. Negative 6 divided by 2 is negative 3, so that we'd get negative 3 over 1, or negative 3. And our x squareds actually end up canceling out completely, right? Two sets of x's cancel, so we just end up with minus 3. So let's distribute our negative 3, again, to all three pieces here. So negative 3 times 2x squared is negative 6x squared. We'll line that up with our other x squared. Negative 3 times negative 5x is positive 15x. Again, lining that up. And negative 3 times positive 3 is negative 9. We go to subtract this whole line through adding the opposite. Let's see, add, make that the opposite, that the opposite, that the opposite. Things we get to cancel out here. My x squared, ooh. Well, those, hey. Everything canceled out. We ended up with 0. And of course, we can see we're at our constant here. This definitely represents my remainder. And so we have our answer. If we write this again in the form quotient plus remainder over divisor, since our remainder is 0, we can omit that fractional part and just write the quotient, which is x minus 3. So it went in exactly x minus 3 times. And again, what does that tell us if I get a remainder of 0? It tells me that what we just divided it by, 2x squared minus 5x plus 3, is a factor of the large term, the 2x cubed minus 11x squared plus 18x minus 9. It's one of its factors. Okay. And x minus 3, what we just found, is its other factor. Is the other factor. Okay. We don't necessarily need to use that part for today's lesson, but we will be using that in upcoming sections. All right, thank you guys. I know this was long division. As you can tell, some of them take longer than others, and it is a long process, but just take your time. Be careful with your calculations, and you can do it. Just have some confidence.